Alright, let's continue. What have I done? All I did right there was just take that first line and just replace it. Okay, I didn't mess with that first line. Now let's do this. Let's actually multiply everything by this negative 5. So negative 5 times 3x is negative 15x. And this is going to be negative 5 times negative. Negative times negative is positive. 5 times 200, or 5 times 2 is 10, isn't it? Stick a couple zeros on there, you get 1,000. Equals, and I got negative times negative will be positive. What's 370 times 5? 1850. Alright, keep that calculator out just for quick use here. Okay, that cancels out. Let's add these. Well, that's easy. That's what? 1,014, right? Oh, I forgot the y there, didn't I? So it's 1,014y. And then you add these up. What do you get real quick? 1850 plus 385. 2,235. Okay. Divide that number by 1014. I think it comes out even. 2.2? Uh-oh. We messed up somewhere. Let's pause this and find out where we made our mistake. Alright, we actually didn't make a mistake. We actually did this right. It was me that made the mistake. It was right here. I just wrote the problem down incorrectly. It's 0.03x. So instead of moving it 3 places, how many places am I moving it? Just 2 places. So let's do this again. Let's go 15x plus 14y. That didn't mess up the top at all, did it? It's the second one it changed. So I'm going to have to move everything just 2 places. So if I move this 2 places, I get a 3x, and then minus, if I move this 2 places, 1, 2, I just get a 20y. And if I move this 2 places, I just get a negative 37. Alright? So, once we do all this, multiply by a negative 5 again, just changes things just a little bit. So this is going to be, might as well do the whole thing. Sorry about that, wasted a lot of time. Alright, so the top didn't change. The bottom is negative 15x. It's plus, what is this this time? It's 100y. Okay, and instead of 1850, it's just 185. That changes things quite a bit, doesn't it? That's 114y equals, what would that be? 570. Yeah. Divide by 114. Plug that in. So y is 5. There we go. I knew it would work nice. So y is equal to 5. What we can do now is we can now do some substitution. We can use any of these equations up here that we want. I definitely wouldn't use this fraction equation. I definitely wouldn't use the decimal. So find one that's kind of easy. Probably this one right here is a good equation to use. So what are we doing? We're putting that 5 in for the y, and then we're going to find out what x is. So let's just do that real quick. It's 15x plus, let's just do this in our head, 14 times 5. What's 14 times 5? That's 70, is that right? Yes, it is. Okay, equals, what's that, 385. Alright, we're solving for x. So we subtract a 70 from both sides, and we've got 15x equals, what, 315. Divide both sides by 15, and there's your answer for x. X comes out to be 21. And there's your 2 answers. There's x, and there's y. So really, all this stuff was kind of review, except for the beginning. The beginning was the new stuff. How do we get rid of the fractions? We just multiplied by a common denominator. You see it? How do we get rid of the decimals? Find out how many places do you have to move your decimals in order to get a whole number. And then you do that to everything. Alright, so we just moved the decimal 2 places to the right, and this is what we got right here. And then we were just left with this problem here. That's a basic substitution or elimination type problem, and then you just go through the rest of it. Sorry for the mix-up right here. We actually were doing this right. We just moved this a decimal over too far. Okay? Alright, let's do another one. Alright. Let's try to get this one right the first time. At least I'll write it down right. So double check with me. Alright, look at the problem. This is 6-3. And not just a square root, it's a cube root of x minus 5 and then minus 2 and then equals 2. Alright, when you see something like this, when you see a square root, cube root, or a root like this, what you want to do first, for instance, if you had, let's go back in time a little bit, let's say if you had the square root of x equals 7, alright? Do you remember what to do to get rid of that square root? You always do the opposite to get rid of stuff, right? What's the opposite of taking the square root? Squaring. So watch, I could square this side, and what do I have to do to this side? I square this side as well. So look what happens. That square cancels out that square root, so x equals 49. What if it was the cube root of something? Oops, not 3. What am I doing? What if it was the cube root of x equals, I don't know, 2? That's right, you got to cube both sides. You see it? Because the opposite of cube rooting it is cubing it. So you cube this side, you cube this side. That cube root cancels, that cube cancels, x equals 8. You with me? So what are we going to do here? How do you get rid of that cube root? No, I didn't. Okay. Come on, what did we just say? We just said it. Cube it. That's all you got to say is cube it. We said it already. All right? You cube the thing. But something's in our way, though. We don't want to cube it just yet. Because if I cube the left side, I'm going to have to cube this minus this. And that's going to be really ugly. All right? Believe me, I'm not going to go through it and show you. Just believe me, it will be very ugly. First thing we want to do is if there's anything floating around that cube. Are you looking? Brian. If there's anything floating around on the outside of this cube root or square root or whatever root they give you, okay, you got to get rid of that first. That's really important. It's not hard to do. It's important to do, though. So I add a 2 to both sides. All right. So now I rewrite it. I've got the cube root of x minus 5. I haven't even messed with that yet, have I? Equals what? Equals 4. You see it? That was easy, wasn't it? Just add a 2 to both sides. Now you can go ahead and do what we were going to do over here. This is a cube root because everything on the left side, the only thing that's happening to this x minus 5 is being cube rooted. All right? How do I get rid of a cube root? Say it. I cube it. That's right. Okay? I cube it. I don't multiply it by 3. I don't square root it 3 times or anything like that. I cube it, or I take it to the 3rd power, okay, if you wanted to say it like that. So what happens? That cancels out with that root. What am I left with on the left? Yeah, I just got an x minus 5. That's nice and pretty. What's 4 cubed? 4 times 4 is 16. 16 times 4 is 64. Okay? Now it's simple. Add 5 to both sides. What's x equal to? 69. All right? Now, you got to be careful with this stuff, though. You have to check it. You know how when you're a little kid, you know, they had you check your answers and all that, and after a while you just quit doing it, you know. On these, you have to do it because weird things happen. When I square both sides or I cube both sides, weird things can happen, all right? And just take my word for it. So you always have to check it because sometimes you might do all the math perfectly right and your answer doesn't even exist. Even though you might get an answer and it looks like it's the answer, that answer may not work, all right? And when will you know that? Well, you won't know it until you chuck it back in and you check it. So let's do that. Let's put it back in. If you put a 69 in here, 69 minus 5 is 64. What's the cube root of 64? It's 4, right? Because we figured out what 4 cubed was, right? So the cube root would be, the cube root of 64 would be 4. So that's a 4. 4 minus 2 is 2. Does it check? Yep, it does check. So before I circle it, I always check those, and then I circle it. And now I can be pretty sure that I got that right. You with me on that? Okay. Let's pause that. Let's do one more that's kind of like this. All right, here's our next problem. This is example 6.4. So example 6.4. Now this is a little bit different. It's kind of looks the same, doesn't it? Because you got a root over here, and you know you figure, oh, how do I get rid of this? I square it, right? But you got to be careful. Remember what we said? Remember that minus 2 was sitting over here on that other problem? Well, now we don't have a minus 2. We have a plus square root of x. I still, since you got a plus in between, I'm going to take this little one and I'm going to put it on the other side. Now you could just square the left side. I'm not going to go through it, but it's really, really a pain because you'd have to do a FOIL method with these two as your terms for FOIL method. Do you really want to do that? No. So I'm not going to square both sides right now. I will in the next step, but not right now. Okay? So first thing I want to do is take this and then chuck it to the other side. And how do you do that? If there's a plus in front of it, how do I get rid of it? I just subtract it. Okay, so I've got this. I didn't mess around with that. Equals, this is going to be 8 minus what? Square root of x. Now we're still going to have to do some FOIL, but the FOIL won't be as bad as if you tried to FOIL that whole left side right there. Just believe me on that. I won't show you. So what would we do? We got that big square root sitting there by itself. Now what did we do in the last problem? How did you get rid of that root if that's the only thing on the left side? This time we square it. That's right. So this time we square it. But this is not just one single number though, is it? On that other problem, what was it? Like a 4, I think it was. And we just, cubed a 4 and we were done. That was easy. This, you got to think a little bit. You got to take this and you have to square that as well. You can't just go 8 squared minus square root of x squared. You cannot do that. Okay, this is the problem that people have all the time. They say, oh, let's just go 8 squared minus this squared. So it's 64 minus x. No, it's not. You have to square this whole thing. What do you do when you square something? You multiply it by itself. That's right. So now this one did get rid of the square root because the only thing on the left hand side is that square root. So that square does cancel that out. So on the left hand side I just get x minus 48. On the right hand side we got to do a little bit with this. If I multiply it by itself, oops, why did I put a 3 there? I don't know. Alright, it would look like this. See that? Isn't that the right thing? Because when you square something, you multiply it by itself. So you can't, for instance, a lot of people look at this and say, oh, it's just x squared minus 4. And you might think the same thing. But it's not. It's going to be x minus 2 times x minus 2. You've got to remember to do that. When you have a parentheses and it's being squared, make sure that you multiply them by themselves. You get it? And I would do some FOIL method here to figure that out. We're not going to do that right now, but we are going to do that here. Just keep this x minus 48 right here for good safekeeping. Now what we're going to do on this right side, this 8 minus square root of x, we are going to go ahead and not factor it, but FOIL it. All right? So let's do that. First outside, inside, last. So if I do the first, what do I get? 64. Didn't give you much time, did I? But it's 8 times 8. Come on. You should be able to answer that right away. Let's do the next one. Let's do the outside. What's that going to be? 8 times negative. Remember, these are being multiplied together. So it's 8 times a negative square root of x. Well, this is how you would write it. You would write it negative 8 square root of x. What about the inside? That's the same exact thing, isn't it? So write it the same exact way. Minus 8 square root of x. Let's do the last now. Negative times negative. Always do that first. Positive. Now let's think about this. What is the square root of x times the square root of x? It's just plain old x. We did that drill before. Remember I said square root of 3 times square root of 3 is 3. Square root of 843 times square root of 843 is 843. Remember that? Same thing here. So I can just put a plus x. What's that? Oh, why do I keep doing that? I don't know why. Why in the world do I make that thing? That's weird. Alright, let's keep going. Watch. X minus 48 equals 64. What I can do is I can add these two terms right here because they're like terms. Negative 8 square root of x minus 8 square root of x is what? Negative 16 square root of x. Watch. This is a nice part about this. Subtract an x from both sides. Do you see it? Watch. The x cancels with this x right here. I subtract an x from both sides. Alright, and let's do this. Let's subtract a 64 while we're at it. Alright, to keep this square root of x here. So that cancels. What's this going to be? It's going to be a 2, and that's going to be a 10, 11. Is that right? Negative 112. Did I do that right? Check my math. Equals, and that canceled, and this is negative 16 square root of x. I'm running out of time, so let's go a little faster. Divide by the square root of negative 16. So let's see, where am I? Do I have that written down somewhere? What is that? What's 112 divided by 16? What is it? 7? Okay. So 7 equals the square root of x. What do we do to get rid of that square root? Square both sides. Guess what we get? X equals 49. Make sure you put it back in there and check. 49 minus 48 is 1. Square root is 1 plus 7. 1 plus 7 is 8. Yep, it checks. We're good to go.